Hello, so here we are. This is question 17, which is part of the WJEC intermediate level back of the paper series. So where I'm going through lots of papers where I'll literally just do the few of the questions at the back to sort of show you there are marks that you can have in those questions. Okay, so here we've got, it tells you that he's having a weekend in Wrexham. What a lovely place to have it. Of course, that's where I live, where I was born and bred. The probability he will visit Earthy Gardens is 0.7. Guess where I was yesterday for about 2 hours? Earthy Gardens. Anyway, the probability of Dylan going to Bersham Heritage Centre is independent of him visiting Earthy Gardens. That's an important thing because it means that whether or not he goes to the Heritage Centre, it doesn't matter as to whether he goes to Earthy Gardens. They're not related. That means we can multiply the probabilities on our tree together. Okay, just something worth noting. The probability he visits Earthy Gardens and goes to Bersham Heritage Centre is 0.28. Complete the following tree diagram. Now, I did start recording this earlier on. Now, this is a paper that I've marked for a student. So what I'm doing is I'm actually recording it for him specifically. But I thought, you know what? I'm going to use this as part of my helping other people with it as well. And plus the fact, it makes me get it done for my students. So let's just have a look at the tree diagram. So it tells you it's a tree diagram. I'm sure you may recognise it if it is. Now, you will notice that on the left-hand side, when we read a tree diagram, we read from left to right. Just like we do when we read a book, any text in the Western world, we go from left to right. So, on the left, we have got we could either visit Earthy Gardens or he doesn't visit Earthy Gardens. So in this particular scenario, that's all we're interested in at this moment. So this particular part is just about Earthy Gardens. Now, with probability, the probabilities of all possible things that you are looking at in a scenario add to 1. So, for example here, let's relate what that means to this example. Well, on this tree, I guess this branch going from there to there are only 2 options. You either go or you don't. So the probability of that plus the probability of not going would add to 1. Okay, so if that's 0.7, what we can do then is put in there the probability of not going, which is 0.3. Okay, and that's simply 1 take away 0.7, and that would be 0.3. Okay. Right then, so then what we do is we consider the scenario of, well, okay, so if he visited Earthy Gardens, what could then happen with regards to Bersham? So that's why I'm going to just use this piece of paper and cover that up for now. So if he went to Earthy Gardens, does it, he'll either go to Bersham or he won't go to Bersham, okay? That's a decision. Now, do we know the probabilities of whether he goes to Bersham or not? No, we don't. But this is where we look in the question and think, right, okay, if it's not been given to us, there must be something in the question that enables us to work that out. So I'm going to highlight something else in a different colour, and that is this bit here. I know it's probably a little bit dark for the screen, but I can tell you, I'll read it out in case you can't see it on the screen on my recording. And that is, he visits Earthy and goes to Bersham. So the chances of him going to Earthy first, then going to Bersham is 0.28. So what I do is I highlight those parts. So like if he goes this way and goes there, that's 0.28. So I'm going to write that on here, 0.28. In using a tree diagram, it's that tongue and brain working at a different speed. The Earthy, so what we do is multiply the 2 together. So 0.7 multiplied by the probability he goes to Bersham is equal to 0.28. So you might be thinking, well, okay, I get that, but I don't know how to work that out. That's okay. So what I'm going to show you now is make sure that you do write down what you know. And that is that the probability of going to Erddig, and I'm just going to put this in shorthand, Erddig and Bersham is equal to 0.7 times something, and we know it's equal to 0.28. Just a note, please don't write in the exam on that side. I'm just demonstrating it on this question here. So so at least you've written that down. You get something for it. Okay, even if you didn't do anything else on there, at least you're showing you understand what's going on. Now, I would have to just double check that with the mark scheme. But in questions where you're not sure how to work something out, don't let that stop you putting down the bits that you do understand, okay? So let's have a look then. So if we've got two things multiplied together and you've got an answer, how do we find that thing unless we can see it straight away? Well, something times something is 0.28. So what's the opposite of multiplying? Dividing. So we're going to do 0.28 divided by 0.7. Oh, nice opportunity there to do some division of decimals. Okay, so what we would do is we would multiply both numbers by 100 to turn it into a fraction that has two whole numbers on it. Okay, now as long as you multiply the top and the bottom by that same number, that's fine. So 28 over 70. Well, let's look at common numbers, top and bottom. You've got 28 and 70. Common factor for both of them is 7. So that would be 4 over 10. I had to think then. When I'm talking on the screen and thinking about where I'm putting it, making sure it's clear on the screen, my brain just pops. But yeah, so it's literally 0.28 divided by 0.7. So in other words, 0.7 multiplied by 4/10. Now, what I will also do is put that in terms of a decimal, which is 0.4. Those two multiplied together, check it on your calculator, you will have 0.28. So what we can do now is we can then just put the rest of those probabilities in. Now, I did 4/10 there, but I'm actually going to put it back into decimals because they're exact. 0.4, 0.6, because remember, that's one branch, starts from one side and then it splits out into two. The probabilities of both of those together add to 1 for that, obviously that individual one there. Same here. The probability he goes to Bersham Heritage Centre, well, again, it's independent of whether he goes here or not. Doesn't matter. So the probability will be the same, 0.4. The probability of not going is 0.6. So what I want to do is to just do something on another piece of paper quickly and just show you, okay? So again, with our tree diagram, we have 4 things that can happen. I'm going to call it Erddig, not Erddig. Just that's my shorthand, I'm just writing. This one is Bersham, not Bersham. And again, this one's Bersham and then not Bersham. Hopefully the captions come up so you know I wouldn't normally just abbreviate. It's just because of the time I've got right now. So this way is, it's modelling one situation, which is he went to Erddig and Bersham. Okay, what else could happen? Well, he could have gone to Erddig and then not gone to Bersham. Okay, so he's just gone to one. Right then, so that's 1, that's 2 routes. Let's go back here and say, well, he could have not gone to Erddig, but did go to Bersham. And he, again, go back to the beginning, could have not gone to Erddig, and also didn't go to Bersham, okay? So there are 4 possible things that could happen, and they're found from going from left to right and following the branches. Quite often what I've done to help students, I've said, well, okay, so that's one route. Getting all the highlighter pens. This is where my great big supply of stationery in my office helps me. So that's another route. So again, where are the rest of my highlighter pens? I can't find them. It's all right. My desk at the moment, when I'm doing lots of things, my desk is just such a mess. Right, so there, and then there. That's another route. And one more, what have we got? Blue. So the other one is that didn't go to Erddig and didn't go to Bersham either. Okay. Right, so let's go back to this question. So we have got on here, I know there's lots of things written down. So completing the tree diagram, as long as you've put the 0.3 in there, and then you'd worked out the 0.4, and then you repeated it on the other branches, that would give you your 4 marks. So on to the next question, which is calculate the probability that Dylan visits Erddig Gardens but does not go to Bersham Heritage Centre. Now, what did I just create? Goes to Erddig but not Bersham. Which colour route is that one? It is the purple, yeah? So that not there, went to Erddig but didn't go to Bersham. Okay, so what's the probability of that then? So I'm going to pop that in pink here, and purple, sorry. That's going, went to Erddig, and then didn't go to Bersham Heritage Centre. It's down there. Just a little note there. You know, sometimes in school you get asked to present stuff. You have to go to the front of the class or wherever it is, and you're like, oh, you know, a lot of people worry about it because they worry that they're going to forget the words, get a little bit tongue-tied or what have you. And you know what? It happens to all of us. It doesn't matter. The more we do that, and the more we talk about, you know, perhaps getting words mixed up and just showing our own vulnerability in that sense, it's okay. And that's why I just laugh it off with me. It's just, yeah, whatever. Right then, however, with me, it's not nerves. I just, brain and tongue just aren't coordinated a lot of the time. Right then, so calculate the probability of that happening. So the probability is, we follow the probabilities of that route. So going from there to there is 0.7. Okay, remember they're independent. We multiply down the branches, so that multiplied by whichever one we're going to do. Okay, so we know, we've highlighted, it's going to go that way and then down there. So that's 0.47 multiplied by the probability of not going to Bersham, which is 0.6. Okay, nice little bit of decimal multiplication there. So what we do is I can tell you for a fact that the answer to that is 0.42. Okay, but how would I do that, Natalie, in an exam? Well, what you do is, I'm going to get a slightly different colour pen here, is you take both of those numbers, so 0.7, and I want you to multiply it by a number, i.e. 10, 100 or 1,000, to just basically turn that into a whole number. And a whole number is like number 1 upwards, but counting in 1, 2, 3, 4, 5 integers. So if we multiply that by 10, we get 7. Oops, equals 7. There we go. We're going to do the same to the 0.6. So 0.6 multiplied by 10 gives us 6. Now, unlike division, we can do different multiplications for different numbers here. Okay, I mean, we could do it for division, but it just makes it a little bit more complicated. So all we're going to do now is say, well, what is 7 times 6? So 7 times 6 is equal to 42. And then, because that's not the answer to the question we were given, because we've just adjusted the numbers to make life easy for ourselves, which is good, we now need to kind of undo the multiplying. So we multiplied by 10 for that number, multiplied by 10 to get that number. So this number is 100 times bigger than what it should be. So what we do is we undo that. So then we divide by 10 first, so gives 4.2. And then we divide that answer by 10 to give 0.42. I'm just checking you're actually on the screen. You can see that. Okay. If you divide by 100, that's okay. Dividing by 10, then dividing by 10 again is the same as dividing by 100. Okay. Another way of looking at it is when you've done your multiplication, this one here, So I'm just going to do that on a separate piece of paper. Let me do it on here. So if you'd say you've done your 0.7 times 0.6, you've recognised I need to like multiply by 10 and you get an answer of 42. Well, what you can also do is look at the numbers after the decimal point, on both the numbers in the question. So you've got one number after a decimal point there, and then you've got another one here. So that means we need to make sure we've got two numbers after the decimal point in our answer. So one number, two number, that must be the decimal point, and put the 0 in there. Those people who are really competent at maths may say, well, that's obvious, that's the same as what you've done on the other one. Exactly. And that shows you that actually they are the same thing, but illustrated in a different way. And that is the key to what I do in my job. I'm not changing the maths. I'm just changing the way that we can look at it and use it. And that is the end for today's question. So the answer for that one is 0.42. Thank you.